Hello, I'm JW. Today we're going to have a look at this, which is a length of pipe, normally used for water, and we're going to see what kind of resistance water actually has when contained inside plastic piping. Now, this is a 1 metre length of plastic pipe. There's actually PEX pipe, and this is commonly used in houses, certainly in the UK, for cold and hot water and heating systems and various other things. And it's basically a plastic thing. And on the end here we've got a piece of copper of the same size, 15mm outside diameter, a couple of joints here, and a valve on the end. And the other end is exactly the same, so another metal bit there with a valve there. So the point is we can fill this with water and then connect onto the ends here and then check the resistance between the two. So here outside, and just got this blue hose here. This is actually normally for washing machines. I'm just going to use this to fill this from the tap, so we're going to screw that on the end there, and then the other end of course will attach to the cold water tap here, and this is direct off the mains water, the sort of thing you could obviously drink if you wanted to. So it's going to turn that on, and I've got a valve on each end so we can flush the water through. So just turn on the tap there, and there's the water obviously going through like that. Now I've got a pressure gauge just attached to the other end here, so if I turn on the water there, the whole thing is of course filled with water, and then if I open the valve there, then the pressure will be displayed on there. It's a bit difficult to see there, but it's about 2 bar, which is pretty much the water pressure we have at this location. And then the idea here is that we can actually close the valves at both ends of that, keeping that pressured, turn off the tap there of course, and then disconnect the blue hose from that, and that will basically leave the pressurised water within the piping. So we can then test that inside afterwards we've done that. And again, there's the pressure gauge there, and you can see we're showing about 2 bar on the side there with it disconnected. So that's pretty much how that works, and it also ensures that because we have water flowing through, that there won't be any actual air or anything sort of trapped inside the pipe there. So here's our pipe here full of water, and I saw there it was pressurised to about 2 bar, and that's about 25 psi roughly or so. I've taken the pressure gauge off because I thought it leaks a bit via this joint. I think it needs a new washer or whatever. So basically just close the valves both ends, so it's now full of the water, and that's water straight from the mains, sort of thing you could perfectly well drink. And the water in this area is fairly hard, so quite a lot of dissolved minerals and whatever inside there. Now we'll check the resistance first of all using this multimeter. This only uses a small voltage to check, probably only the battery voltage, which is a 9-volt thing in this case. I'm just going to use these leads here, just clip directly onto the copper pipe at either end, so we're just measuring basically the water itself. So let's just zoom in a bit so we can see the reading, and then we'll just connect up and see what we've got. So basically over limit there at the moment, so we'll just connect up the lead to the pipe at the end here. We can see we've got some sort of reading on there, so that's in kilo ohms as we've got on the side here, so it's about 180k, and that's basically between the two ends with a 1 metre length of water between. And being that's only a tiny voltage, so I'd like to getting some sort of reading on that. So 180k, or just say 179.7, so say 180k for that. Now I'll do the same again, just got the lead still attached here, one at either end of the pipe there to the bits of copper. I'm going to use this one, which the main difference here is this can test from 50 to 1000 volts rather than just a few volts of the multimeter. I'm just using the multimeter here as a stand just to prop this up so it's easier to see. And the deal with this one is the resistance is here, which is actually in megohms, and then the voltage applied is displayed at the bottom corner down here. And a little select here just for the various voltages. So just zoom into this so we can get a closer look there. So we're going to start out with the 50 volts here, so let's see what we get with that. So they've got 0.19 megohms and 53 volts. So basically that's pretty much the same as we had before, so 190k. So again, pretty much what we got from the multimeter with just a few. So let's move up to 100 volts. And again, pretty much the same, and again 104 volts DC applied there. Next we've got 250 volts. That's actually interesting, coming out slightly less, so 0.18, but realistically it's within the same kind of area, sort of 190k or so. And then we go up to 500, which is what you'd normally use for mains voltage installation, so try that one. Now still came out to 0.18, but interesting enough the applied voltage is actually only 285, rather than the 500 we wanted, because it's actually limiting the voltage internally to limit the amount of current that flows through. So though we can go to 1000, we'll probably find it won't actually go there. Yeah, again, it's only applying about 290 volts, and we're getting basically 0.2 megohms. So again, that's sort of 190k or so that we had before. So it's pretty consistent between sort of nothing and about 280 volts or so. And so sort of 190k seems to be the sort of area that it's in. Now, just because we can, and we've also got it, we can actually use this horrendous device, which is another megohm meter. This is a Chinese one made out of solid plastic, and this actually goes up to 1000 volts and has the analog scale on the front here. So I'll just clip this one up. It's got its own leads. Unfortunately, they don't have the standard connections. It's got sort of binding post type things. So we'll just do this and get a closer view of the display and see what we get with this one. So here's this one all connected up. This actually goes from 0 to 1000 megohms. The 200k obviously is going to be down this end here, where it says 0.2, assuming that's what we get. So let's crank the handle and see. So this is all basically down the bottom there at the sort of 0.2 area. And just to check this is working, just disconnect the other lead here, and then we just crank the handle. And sure enough, it basically goes up to the top end of the scale there. So 200k seems to be about the value of this thing, and that's say for a metre of water in between those two pipes there. So the value is 180k, and that's for a 1 metre section in that 50mm piping, and that's 50mm outside diameter. The inside, of course, is somewhat smaller, and that would actually be a fail if you were testing your electrical wiring, as in that case you're looking for many megohms and certainly a minimum of 1, and in reality tens or even hundreds. But important thing to note there is that 180k, if you put the 230 volts between the two ends of that, as in the normal mains voltage in the UK, the current that would flow across that 180k is only going to be around 1.2 milliamps, which is pretty much nothing in terms of electrical systems. And even if your fingers or your body was in there somehow and there was 1.2 milliamps going through your body, the realities are you probably wouldn't even feel it. It most certainly wouldn't cause any major damage or death or anything. And again, perspective there is that the RCD in your house, which typically would protect the sockets and other items, that's only designed to trip at a current of 30 milliamps, considerably more, of course, than the 1.2, which would flow through the water in that piece of piping. So certainly it's a very small amount, and bearing in mind that's only 1 metre, and typically the pipes in your house are going to be considerably longer than 1 metre in length. So that's going to be it for this time, and next time we may have a look at other things inside the pipe, but until then, thanks for watching.